So this is the problem that I have chosen for our problem-solving walkthrough. It is a static rotational equilibrium problem. So first we have part A, in which we need to find the force that support number 1 has on this system. So we can start to isolate support 1 by using support 2, this spot right here, as a pivot point, so that we can take it out of the net torque equation. All right, so keeping in mind that the torque is equal to the force times the radius times the sine of theta, so making sure that it is the force that is perpendicular to the radius that is around the pivot. So to sum the torques, we would have all of the torques going counterclockwise equaling the ones that are going clockwise. So using support 2 as the pivot, we have 2 torques going in the clockwise rotation, and 1 torque going in the clockwise rotation and 2 counterclockwise. So 2 counterclockwise, we have the person and the beam, and then the one that we have clockwise is going to be support 1, which is what we're trying to find. So here we have support 1, so we'll define that as force 1 times the radius of 1. And then for this specific problem, since the support 1 is already perpendicular to the beam, and the person and the beam itself are perpendicular to this pivot of rotation, the angle will be 90 degrees, and since the sine of 90 degrees is just 1, we can eliminate that from the equation. So here we have force of support 1 times the radius of support 1 is going to be equal to the force from person times the radius that they are at, plus the force from the beam times the radius of the beam. So now we can use the given values to solve this equation. So start by keeping force 1, which is what we're trying to find. And then here, using support 2 as the pivot point, the radius that the force from support 1 has is 3 meters from support 2. So we'll write 3. That will be equal to the force from the person, which is the force due to gravity. So we have the mass of the person times gravity times the radius of the person. And then same thing, the force from the beam is also gravity. So then we have the mass of the beam times gravity times the radius of the beam. So 3 times force 1 equals mass of the person. We have 86 kilograms. So 86 times gravitational constant, so 9.8. Radius of the person. They are 2 meters from support 1, and since support 1 is 3 from support 2, we know that the distance, the radius right here, is going to be 1 meter. So 1. And then next, the mass of the beam, which says here is 90 kilograms, times gravity, which is 9.8, times the radius of the beam. So we assume that the beam has a uniform density all the way across, which means that the center of mass would be in the middle. Half half of 3 is 1.5. So that is our radius. Okay, so now we can use our calculator to narrow this down to find what the force is. So 3 times the force of support 1 is going to be equal to, this is equal to 842.8 plus 1,323. Add those together, 3 force of 1 is equal to 2,165.8, which leaves force 1 to be equal to 721.93. Then we gotta remember, last step, to use sig figs. So see here that we need 2 sig figs. So you can say that is approximately equal to 720. Remembering our units here, we have force, so newtons. And that is the answer to part A. All right, so now on to part B, where we need to find the force from support 2. So unlike the first part where we used a sum of torques equation, for this problem we're going to use a sum of forces equation. And keeping in mind that from part A we already found that the force from support 1 is equal to 720 newtons. So the way that we're going to do this is similar to how we summed the counterclockwise and clockwise torques in part A. We are going to set each side equal to the upward and downward forces. So for this problem, that is going to be the force from support 1 plus the force from support 2, and that has to be equal to the force down from the person and down from the beam. So and the reason that we're able to do this is because since we know that in this system, we're in an equilibrium since nothing is accelerating, we're able to set everything pushing up equal to everything pushing down. So now we can start to enter some of the information that we already have. So we know that force 1 is 720 newtons, so 720 plus whatever support 2 is, has to be equal to, similar from how we had the last problem, mg. This time there will be no radius though, because since we're not rotating, since it's not torque, the radius doesn't matter, it's just the force. So the mass times gravity, so that will be for the person, we have 86 times 9.8 plus 90 times 9.8. All right, so now using our calculator, we can find these two are, and then find the force of support 2. So first, going to move this 720 over to this side, so we'll have force 2 equals, we'll have 842.8 plus 882 minus 720. All right, so adding these two together, we get 1,724, fix that 0.8 minus 720, which will be equal to 1,004.8. And then once again, using significant figures, rounding this, have to make it so that F2 is approximately equal to 1,000 newtons. And there, now we found support 1 and support 2. the forces using rotational equilibrium and the sum of forces and sum of torques.